Section 11.9, how to solve the second degree inequality. So what we did practice about the first degree inequality, but now when you're dealing with the second degree. In this example, x2 plus 3x minus 10 greater than 0. This is a second degree because power of x is 2. There are several ways to break this into two parentheses. You could either use a quadratic formula or just factoring. To do the factoring, you find two numbers whose multiplication is negative 10, and when you subtract is positive 3. So when you break it into two parentheses, then you take each parenthesis, set it equal 0. That gives you two numbers, x equal 2 and x equal negative 5. When you graph these equations, you notice that when x is greater than 2, like x equal 2, x equal 3, the graph is above horizontal axis, means it's all positive. Or when x is less than negative 5, like negative 6, negative 7, the graph is above horizontal axis, or y is positive. Y is negative when the graph is between these two numbers. So solving inequality means in the beginning, we are looking for some values of x that when you substitute, the outcome is always positive or greater than 0. So those values are greater than 2 or less than minus 5. So that's the main difference between first and second degree inequality. Let's say I want to solve the first degree inequality. This is the first degree. What number plus 3 is greater than 0? There are so many numbers. To do that, we show it on the number line. Number line, positive infinity, negative infinity. First, I take x plus 3, set it equal to 0. X is negative 3. So I label minus 3. It doesn't have to be scaled. Just pick a point and just say minus 3. So there are two sections. One is greater than negative 3, all the numbers greater than negative 3, like negative 2, negative 1, 0, and then one is less. So we want to have numbers that when you substitute for the x, the whole thing is greater than 0 or positive. So in that case, you pick a number from minus 3 to positive infinity, any number. Let's say we pick like 1 or positive 1. When you put 1 here, 1 plus 3 is 4. So all the numbers greater than minus 3, when you substitute, it gives you positive numbers. And below is negative number. Problem is asking for the value of x that when you substitute, the outcome is always positive. So you don't, so all the numbers are between minus 3, positive infinity. That's all the first degree inequality. Now, how do I solve the second degree inequality? Like this one. When you multiply these two, you end up having the second degree equations. So to solve that, first you take each parenthesis, you set it equal to 0, you find two x's, negative 3 and negative 5. You label those on the number line. Now I need to determine all the numbers greater than minus 3. Would that make the whole thing positive or negative? So for that, you just take a number like x equal 1. Let's say x equal 1 is here. You take a number, arbitrary number, greater than minus 3 and less than positive infinity. You pick a number here. You substitute that number here for x. The outcome is positive number. So that means when you substitute any number greater than minus 3 into this equation, the outcome is positive. Now, if I pick a number between these two and substitute, like minus 4, the outcome is negative and positive. Problem is asking for the positive numbers. So that means all the answers are between these two, -3 and infinity, and this two. So any number between -3 and positive infinity, if you substitute here for the x, the outcome is always positive. Or if the number is between negative infinity and negative 5 and negative infinity, the outcome is also positive. This is the answers. And to connect these two, we always use the letter of U as the unit. The second problem is you have more than 2 parentheses, you have 3 parentheses. From the beginning, we are looking for some numbers that when you substitute for the x, the outcome is always positive. Okay, so first we take each parenthesis, set it equal to 0 and solve the x, or x is always opposite of what you see in the parentheses. Like here, -6, x is 6, +1, -1, -2, 2. You label those points here. You draw the vertical line. Now I have 1, 2, 3, 4 different sections. Now I need to determine whether I have positive or negative between 6 and infinity. Pick a number between 6 and infinity, arbitrary number. I'll pick like 8. Take that 8 and substitute for the x, and then multiply the whole thing to see if it's a positive or negative. See, it's positive. So that means any number between 6 and positive is 6 and infinity is positive, and they kind of alternate. So if you find this, you don't have to identify the other one. They always alternate. So positive, negative, positive, negative. Then look at the original symbol of the problems. We are looking for all the numbers greater than 0, I mean all the positive ones. We don't want negative. We don't want these two sections. So crosshatch this. So all the answers are between 6 to infinity and also between 1 and 2. That's how you write it. Again, the original symbol determines whether you want a positive section or a negative sections. What's the main difference between fractions and not fractions? Is first we take each of these equal to 0. You label those. You try a number like x equals 0. Any number between this is arbitrary number. I'll pick 0. When you substitute 0 here, it gives you positive 3/5. So that means here is positive, this is negative, this is positive. The only difference is when you do the final answers here, if there is a number that would make the denominator 0, like -5, do not use the bracket for it. Just use a parenthesis. Okay? So let's say you want to graph this, x greater than 2. On the number line, you pick a point which is 2, and you use a parenthesis because it doesn't have equal sign. But if you have x greater and equal to 2, then you need to use the bracket. So when there is an equal sign along with that inequality is the bracket. If you don't see any equal, then it's just a parenthesis. And that's what we're using here. See, for -3 is the bracket, but not for -5. Why? Because it's at the denominator. It cannot be -5. If you put -5, it's undefined. So just in case of fractions, the process is very similar. It's just the number that makes the denominator 0. Do not use the bracket, use the parentheses. Like this one, there are 3 parentheses. One would make it, one is a denominator. X is 17, -18, and 20. You label all 3. Again, you try to find a number like x equals 0. Just pick a number like x equals 0, which is somewhere here, right? between minus 18 and 17, I'll pick 0 here. Put 0 here for x. All we care is just the sign, whether it's positive or negative. We don't care about the the number. So I didn't have to even calculate the whole thing. So it just tells me that when you put a 0 for x, the outcome is always positive number. All right. So this is positive, negative, positive, negatives, alternate. Problem is asking for all the numbers that make it less 0, means looking for a negative number. That means I don't want this section, I don't want that section. I want numbers between 17 and 20 because this make it negative, and this make it negative, so between minus infinity and minus 18. So first you determine sign of plus or minus, and then at the end you look at the symbol of the original problem, whether it's asking for positive or negative number. Same thing here. I want all the number which is positive. I'll pick a number between minus 2 and infinity, like a 0. 0 would make it 10 positive. So this is positive, negative, positive. We are looking for positive number. We don't want this. So all the numbers are between these two and that. This one is, you want all the negative number. Very similar to that. So in this case, all the numbers between these two numbers, between 4 and minus 18. And because there is an equality sign here, remember you put a bracket, or you could also show it like this. Either one is correct answer. Now, most of this problem, we already factored it for you. So what if you have a problem like this, which is not factored in the second degree? So what you need to do is you could either use the factoring method. You open two parentheses, you put x in each, you find two numbers whose multiplication is that, and when you subtract is -2, and then the rest is very similar. So if it's not factored already, you need to do it. If you want to solve the inequality, you want to make sure that all the terms are on one side and less are greater than 0. 0 has to be on this side. You cannot have a number on this side if you want to solve the inequality. But that's what I do first. Now here, since the x is kind of radical numbers, you cannot really use the factoring. So I would use the quadratic equations. When you solve the quadratic, you come up with two answers, 2 plus or minus radical 6. 2 minus radical 6 here, 2 plus radical 6 there, and then pick a number between, like 0. When you put it here, it's negative. The symbol of this problem is negative, means all the numbers between these two is the solution of that form.